Okay, welcome to video 6 in the demonstration videos for our introduction to R. Here we're going to look at better plotting. After video 5, where we did the basic plotting. We're going to say no to these awful dynamite plots and learn how to make better ones using a package called tidyverse. So to install packages, there's a few ways. We can run this code here on line 195 to install the package and then activate it with the library command here on 196. Or we can go to install packages here. So we click on this install button beside update, go to our library is cran by default. We don't need to change that. We type in here tidy and verse like that. We select the library that we need that is installing to this location on our computer. We hit install next and it says install dependencies as well. So that might install a few additional things. And if you see this prompt appearing, just hit no. You don't need to restart R. So now it says that it's installing that packages, and it says I've in fact installed it already. So I don't need to install it, but I do need to activate it on line 196. So there we just type in library and the name of the library without quotes this time, library tidyverse, and that activates the library so it now works. So if we scroll down this panel here, you can see all the libraries that are out there in the R universe. You can see there we have tidyverse working, and maybe use other libraries like tidyr too. So it's just to install that. Remember, it's just hit the install button like that and type in the package there. So what we're going to do next is create a bundle of case controls using this OR norm function that we learned about earlier. So you might have maybe 10 of each, like the example here. 10 with a standard deviation of 11 and maybe a mean of 11, a standard deviation of 1. That will generate 10 values like that. So you can see 10 values around 10 or 11 or so. If we had just 2 values, we would give for the first argument, we would get just 2 values. If we change the standard deviation to be 10 and change the number of values you want to be 5, we'll find that they're around 11, but quite varied, as you can see there. If you change the standard deviation even further, they're going to be very, very different as well. If we change the standard deviation to be something that's really, really small, they're all going to be nearly 11 or thereabouts. So let's generate 10 values with a mean of 11 and a standard deviation of 2. You can see those values and note that it's different every time. So every time we generate these, they'll be around about 11 on average collectively, but they will be different every time. So what we could do is generate a set of cases using this function. And what we can do as well is do the same for our controls. Controls as well. We're just going to compare these two different groups. Numerically, we can do that by just using the summary commands to get some basic summary information on the data that's inside there. So you can see the minima are similar but different. Same for the 25th percentiles. The medians of the cases are lower than the controls, and then the maxima are different as well. What we can do here, just to illustrate that if you had an erroneous reading, maybe in 2 of the controls just by accident, you got, high values, you got values of high-ish values, maybe 13 and 14. We can add them in there. Now we see the controls are slightly different. And their mean is now a bit higher than before. What we can do next is look at this function on line 203, which looks complex to set up the data frame. Is more easy really than it looks. So what it's doing is that we're using the rep function to repeat the cases and controls. So we can take that bit of code and see what that's doing. So rep, and it's doing this, repeating controls and cases many times. And it's saying we're going to repeat it 10 times because that's the number of samples that we have. So you get controls, cases, and so on 10 times. And what you see next is that in this complex command, we have a C command for the text, rep command to repeat it whatever number of times. And then inside the factor is also these levels, which allocate these two items to groups. So we want factor at the start. So if we assign these a factor without the levels, we see that we have cases and controls all the way through. So we can add in levels here to just allocate them into two discrete groups, which makes it easier to compare them using the text form like that. So now we can see that we have a factor with two levels of controls and cases. So now we can allocate this to a label. Let's call it fac1. And then we can say even view fac1. So this doesn't show much because it's not a data frame. So an easier way to view that is simply just to type in fac1 here. We can see, as before, we have controls and cases listed there. So now to create our data frame, which is our goal, we have our first parameter, which is our labels. We just type in fac1. And then our next part is our data, which you can see there is just groups or just the cases and controls together. So C, controls, and cases, and that's the numerical data that we have. And that will be correspond to fac1. So if type that in, that will generate a table. You can see there with our controls and cases together. What we might be nicer to handle, you see the default is to make it gives this column name, which is quite cumbersome to use. So what we can do is, that's why we're using the groups command. We'll just use G here. G is equal to C cases and controls, so that we now have this as the column name, which is easier. So next, we can then assign that to a variable name. We'll just call it dat for simplicity. And we can view that as a data frame. So there we go. We have the case and controls combined together there. We can sort them into the different groups. That's the controls, that's the cases. Combined there together. What you note there is that the cases and controls are now interleaved, so those values didn't correspond. So we need to actually look at this function further and think about it more carefully to create it into the right format that we want. So what we need to do, in fact, for this function is to split it up into two separate commands. So if we repeat, we're just going to use rep, and then the C function, because we have text. Oh dear, controls. We want controls. Are going to be first in our parameter, so that's why the first here. I'm going to repeat that 10 times, so you get 10 controls like that. And then we can add to this. So we just add the same code for C cases, capital C, 10 times as well. And then what we do at the start and at the end is just put a C function around that to wrap it all together. So C is a general concatenator. So then we have controls and cases. So that differs to our original factor because we have controls and cases interleaved. Now they're separate. So now we can just add to that. Fac1 is assigned the value of the factor containing all this with our levels. Oh dear, how do I go to the end? Levels at the end. Levels equal to C controls and cases. So levels just denote the different groups that are present. So now we can check fac1. So if controls, 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 cases, 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 which is the order in which we're giving the data in. So now we can go back to our original command for the data frame. This one. So controls first, then the cases. So let's now view that. So you can see there, we have our original controls with the values of 13 and 14 in elements 7 and 8. And then our cases are down here. So now we can proceed to the next step, which is to plot it using ggplot. So before we learned plot that would plot the original values for each of the groups. So you can see there we have the two different groups here are recognized by the levels. You can see there's a bit of a difference between them. We can do a histogram of that, but the histogram is not as effective because this is a data frame with two different groups. We can do but we have a block spot shown there. So what ggplot is doing here is it's piping the data out so that we have our input data as X, and then we have the groups associated with it. So if we look at that, it has FAC1, the labels, and then G as the actual values itself. So if we look at our data there, what we can do is take our data and just pipe it out to ggplot. But note there are some differences that we'll have to account for. So use this function ggplot, and it takes in one key parameter, which is the aesthetics, which is basically the things to plot. Note here that in our original function, we called X is equal to the factor, which is all this information here. Whereas in our code, we actually called it fac1. So that's the labels. And the second thing is basically the data here. So we called it data G instead of groups. So we need to change that to G. And this will do a basic plot with ggplot, as we can see there, except nothing is shown. So we need to add on further parameters to show the information there. An example of that is of GEM jitter, which shows the original lines, original data points we had. We change that width to maybe 0.4, and that will show the points on the graph like that. So you can see there's a lot of variation between controls and cases. We might change the Y lim, which is the limits of the Y parameter. And if we're plotting like this, we should really change it to be going from 0 to the maximum data point, so that we're not cutting the scale. So you can see there casing controls listed there. And what we might do is change the jitter to be a smaller level so you can see the two groups more easily. So that kind of brings them more close together. So if you have a lot of data, you can use a bigger jitter width. Another thing we can do is layer onto this the box plot parameter. Note that this should go before. It's like we're building up layers here. So this goes before the GEM jitter so that you can see the data points on top of the box plot. So that's why we formulated it in this way. Box plot is here, then jitter after. So you see there the box plot is behind the jitter. If we reverse that, the actual data points will be covered by the box plot. So you can see here we had the points on top, and now we have points behind, which is not ideal. So that's why we sometimes the functions have the functions in particular manner, a particular order. So there we can see our data sets. So this is kind of a brief introduction to RStudio. It is other packages like ggridges. So the same way we can install it again, we install the library, just run the code, give it a minute to access the library and install the dependencies. And what you see down at the bottom is that it should successfully install it. It's currently downloading it. And then it says ggridges is successfully unpacked. We activate the library. So if we're using ggridges, just note, I should probably put a note here. Note that the factors and data argument order needs to be switched. So you can see here, we're going to look at data, and then pipe it to ggplot as before with the aesthetics. Parameter is being the key thing we want to change, except this time we put the data first, then fac1 after that. And then we can add in the function GEM density ridges, just give it a slightly different scale. If I can spell ridges, scale equals, let's say 0.8. So you can see our plot here, the pairing of the cases and controls, so we can compare them directly like that. And we just have to change the G and fac1 order because the orientation of the plot has changed. So the variable now is on the x-axis. If you change the scale down to 0.2, you can see that they're going to be much more flat. If we change the scale to 1.2, you can see they're going to be much, much wider. And we can even add in more data sets if we wanted to in there as well. It can plot many different things. So if we want to make a fancy new plot, we could follow this code and create a new one in the same way as before. So we could just run that. You see it's creating a new variable dat2 with the same factor setup as before, but it's grouping the controls and cases all together to create more groups. So we should be able to plot that, and it will create 4 groups now. So you can see there, you can plot multiple groups as well. So you can try your own example with GG ridges in your own time, and this is the end of video 6.